Hello everyone, this is Harshini and Raj studying in Sri Venkateswara College of Engineering, Bangalore. And in today's video, we'll be studying about the Intelligent Storage System. Introduction. Intelligent Storage Array are advanced versions of RAID array that offer improved data processing abilities. These storage systems use a large amount of memory called cache and multiple data pathway to optimize performance for programs that require fast data access. Intelligent storage systems are built with four main parts: the front end, cache, back end, and physical disk. Components of intelligent storage system. In the Under the components, we have the host and then the connectivity, front end, cache, back end, and the physical disk. Now let's learn each in detail. Front end. The front end acts as the middleman between the storage system and serves as a host that needs to access the data. It has two main parts: front end port and front end controller. Front end ports. These ports allow the servers to connect to the storage system. They support various communication protocols like fiber channels, ISCSI, FICON, and FCOE. Front-end controllers. These controllers handle data transfer between the servers and the cache of the intelligent storage system. They are built with redundancy, meaning that there are usually multiple controllers for high availability in case of one fails. They also contain processing power to manage these data transfer and communication. Cache. Cache is a type of temporary high-speed memory that is used to store frequently accessed data. It is made up of semiconductor memory, which is much faster than the permanent storage devices like hard disk drives found in intelligent storage system. By storing frequently accessed data in cache, the system can access this data much faster than it has to revive it from the HDD each time. This significantly improves the performance of the storage system. Typically, accessing data from the cache takes less than a millisecond, whereas accessing data on a rotating disk can take several milliseconds due to seek time and rotational latency. This is a simple structure of cache which has page, data stores, a tagram, and a disk. The cache is organized into pages, which are the smallest unit of the data that can be stored in the cache. The size of a cache page is configured according to the typical size of the data application using the storage system tend to access. The cache itself consists of two parts, that is data store and tagram. Data stores. This part of the cache holds the actual data that is being cached. Tagram. This part of the cache keeps a track of where the data in the data store is located in both the cache itself and on the disk. Tagram tagram entries include location information, bit flag, time-based information. Location information. This indicates where the data is found in cache and where it belongs on the data. Dirty bit flag. This flag indicates whether the data in cache has been modified since it was copied from the disk. If the data has been modified, the dirty bit is set. This lets the system know that the data needs to be written back to the disk before it can be overwritten in cache. Time-based information. This information such as the time of the last access is issued to identify cache data that has not been accessed for a long period of time. This data can be evicted from the cache to make room for new data. Next, we have the backend. The backend acts as an interface between the cache and the physical disk. It consists of two main components: backend port and backend controllers. Backend port. These ports allow the backend controller to connect to the physical disk. They typically use high performance connections such as SAS, that is serial attached SCSI, and SATA, that is serial ATA. Backend controller. These controller manage data transfer between the cache and the physical disk. They also perform additional functions like error detection and correction, RAID functionality, unlimited data storage. Under error detection correction, backend controller uses algorithm to detect and correct errors that may occur during data transfer between the cache and physical disk. Redundant array of independence disk, that is the RAID, is a technology that uses the multiple physical disks to store data. Backend controllers can implement various RAID levels to improve data redundancy, performance, or both. Limited data storage. Backend controllers may also have some amount of their own built-in temporary data storage. This data storage is typically much smaller than the cache, but it can be used to improve performance by staging data that is about to be written on disk. For high data availability and protection, storage systems are typically configured with dual backend controllers along with multiple backend ports. This redundancy helps to ensure that the system can continue to operate even if one of the backend controller or port fails. Physical disk. A physical disk restores data persistently. Physical disks are connected to the backend storage controller and provide persistent data storage. Modern intelligent storage system provides support to a variety of disk drivers with different speed types such as FC, SATA, and SAS and flash drives. They also support the use of mix of flash, FCs, and SATA within the same. The types of intelligent storage system. We have two types. There is active configuration and one other one is active passive configuration. Intelligent storage systems are classified into two high-level groups. High-end storage systems. These systems are designed for large enterprises that need to be centralized like corporate data. They are built with features to maximize performance, availability, and scalability. High-end storage system typically employs a redundant configuration known as active-active. Mid-range storage system. These systems are designed for small and medium-sized business that may not require the same level of performance or scalability as high-end system. They are typically more affordable and easier to manage than high-end system. Mid-range storage system often use an active-passive configuration. In this configuration, there is a primary controller that handles data requests and a secondary controller that takes over the primary control when the primary controller fails. Targeting affordability and reliability for business. Mid-range storage systems are designed specifically for small and medium-range business. They prioritize striking a balance between affordability, performance, and data protection. While they may not offer storage capacity and cache compared to high-end options, mid-range system excels in redundancy. This is achieved through their dual controller architecture. Each controller acts independently, equipped with their own processing power, cache, and disk connection. This ensures that even if one controller fails, the system remains operational, safeguarding crucial business data. Performance and backup capabilities. Despite their focus on affordability, mid-range storage system drives strong performance capabilities, making them ideal for application with predictable workloads. Additionally, the system offer built-in features like local and remote replication. This replication functionality allows for automatic data backups, further enhancing the reliability and security for their valuable information. And that's all in today's video. Thank you.